Right, there they are. We want to find all of the exact solutions at a given point, between 0 and 2 pi, it says, right? And this is where I said that making a substitution can help. Let theta equal whatever you're taking whatever's inside the parentheses, let's say. So this is homework 9. Is that what you're asking, Lizzie?
No, is it number 3?
Which problem am I doing? I haven't decided yet. I mean, you guys did 3 through, where'd you go up to, 36?
36.
Okay. So I guess maybe I'll pause for a second and I'll just ask you, maybe kind of give me an idea, what questions do we want to cover today? So yeah, let's do some of these problems from page 871, and let's start with number 3. So, number 3 says the sine of negative 2x is equal to square root of 3 over 2. And what I like to do is I like to kind of start off with this equation. The sine of theta is equal to square root of 3 over 2. That's an equation I know how to solve. Right? I can figure out what theta is. And then what I'll remember is that I did a substitution here, right? What I did was I let theta be negative 2x, right? And when I do that, then I solve this equation. And we know that a trig equation has infinitely many solutions. We understand that, right? One of them I could get by doing theta is the inverse sine of the square root of 3 over 2, right? Matter of fact, I think my calculator's ready. I'm going to go ahead and do that. So I'll just to kind of emphasize that I understand inverse trig, I'm going to type inverse sine of square root of 3. Of course, you don't have to do this. You guys already know one of the answers probably from the unit circle. If you just draw a picture, you're going to get this answer. Oh, 60, is that in degrees or radians? It sure is. How many radians is that? Pi over 3. So the picture that goes along with this is I know that if my theta is 60 degrees or pi over 3 radians, what point is that on the unit circle? That's the point 1/2 square root of 3 over 2. And I know that if this is my theta, that is the sine of theta. And so theta here is pi over 3. That's one answer. Theta is pi over 3. But I also understand there's going to be another answer on the unit circle between 0 and 2 pi. Right? And so where would that be? Well, over here, right? I understand that over here we have the point negative 1/2 comma square root of 3 over 2. And again, I'm in business. Right? So I have to ask myself, so what point are we what angle am I talking about there? Theta equals, what would that be? 2 pi over 3, right? I mean, again, I need a 60-degree reference angle. And you know, we spent all that time memorizing the unit circle, but it just keeps coming up again and again. And I said there's infinitely many solutions. That's 2 of them, right? What are the other ones? How do you get the other ones?
By adding 2 pi k.
You add 2 pi k. You either rotate around this way another 2 pi, or you rotate around that way another 2 pi. Okay? So for example, you know, when I say plus 2k pi, I could be going around like this, for instance, okay? And when I say plus 2k pi here, there are infinitely many solutions, okay? So I guess one thing I could do is I could start listing them. I could say, here are different values of theta. Theta could be pi over 3, 2 pi over 3, pi over 3 minus 2 pi, 2 pi over 3 minus 2 pi, pi over 3 minus 4 pi, 2 pi over 3 minus 4 pi. There are lots of solutions. I can put dot, dot, dot. And it's funny because when I did this last week, I think I was putting plus more often than minus. But here I decided to put minus. And I think you'll see why in a moment. Because these are all different things that theta could equal. But remember, what does theta equal? So what these equations really say are things like this. Negative 2x equals pi over 3. Negative 2x equals 2 pi over 3. Negative 2x equals pi over 3 minus 2 pi. Okay? And again, there's infinitely many equations. I'll put the dot, dot, dot over here. Okay? So now what am I looking at? Well, I could solve for x. And I could figure out what values of x work. Now, if I solve this equation for x, I get x equals what?
5 over 6.
Yep. But I need a negative sign too, right? Because I'm dividing by negative 2. So negative pi over 6. And if I solve this one for x, I'll get x equals negative 2 pi over 6, which is the same as what? Negative pi over 3, right? And you notice this is not in the interval 0 to pi. Actually, neither one of these is, right? Those are both negative answers. And it's not really what I want. I want positive answers. Okay? So that's one of the reasons that I started subtracting some 2 pi's here. And I want to show you graphically what we're doing because I think it helps. If I go to the picture and if I type in the function y equals, say, the sine of negative 2x. Okay? So I'm going to graph this. And let me, for the zoom, choose zoom trig. That gives me a nice window. So here's my sine function. It's the sine of negative 2 times x. Okay? And now, I'm also going to graph under y2 what we want this to equal. What do we want it to equal? Well, the original equation said that sine of negative 2x is supposed to equal what? So let's type in square root of 3 over 2. Divided by 2. And now let me sketch that graph. Okay? Now what is it that I just found? I found 2 possible answers. They are negative pi over 6 and negative pi over 3. Let me show you where those are. If I hit second calculate, or second trace, and it says a value, let me type in negative pi over 6. Oh, I know why it didn't work. I'm in the wrong mode again. Let's check that out. Always start in radian mode. Okay, let's graph again. Ooh, now that's kind of funny, isn't it? That's because I'm going from 0 to 360. Let's try zoom trig again, and it should go from 0 to 2 pi in radian mode. Okay, so now I'm happy again. And let's go second calculate a value. And let's throw in negative pi over 6. Because I want to show you that that is one of the solutions. There it is. You guys see it? On the picture, you could see negative pi over 6. Can you see negative pi over 3 on the picture? Well, I would move a little bit which way? To the left. You see that one? There's a couple places that intersects, but it's also going to intersect here and here, and it's also going to intersect here and here, and here and here. As a matter of fact, we said there are infinitely many solutions, and I've expressed them if I write 2 pi k. But the book wants me to go a bit further. They say, hey, find all the solutions between 0 and 2 pi. As I look at this, I'm counting, and I'm seeing 1, 2, 3, 4 places that they intersect. Does that make sense to people? And because I want my answers to be positive, that's why I thought maybe this is the way to proceed. Negative 2x is pi over 3 minus 2 pi. See, if I want to subtract these values of pi, how do you write 2 pi as a fraction? Well, you can always write 2 pi over 1. And can I subtract those fractions? Only if I get what? Common denominator. So let's rewrite the equation this way. Negative 2x equals pi over 3 minus, how many pi over 3's would I have? Well, I'm going to multiply top and bottom by what? By 3. So I'm going to get 6 pi over 3 here. So now my equation says negative 2x equals, what would it be? Negative 5 pi divided by 3. And so x is going to be positive, because I'm dividing by a negative, 5 pi over what? Over 6. That is definitely one of the answers. And let's just see that here. Okay? So if I go back here and hit second calculate a value, and let's throw in 5 pi divided by 6, boom. There's one of the answers. Right? Doesn't matter if I click up and down, it's a point of intersection. Do you guys see that? Okay? And there are others, right? There are others. So how would I get another one? Well, let's see. This one didn't work, this one didn't work, this one did work. And now I'm going to try this. Negative 2x is 2 pi over 3 minus 2 pi. Right? Negative 2x is 2 pi over 3 minus 6 pi over 3. Negative 2x is negative 4 pi over 3. And if I divide both sides by negative 2, it looks to me like I get positive 2 pi over 3, right? Or 4 pi over 6, however you want to say it. And notice 4 pi over 6 is just a little bit to the left of 5 pi over 6. That's going to be that solution right there. You know, and just to make sure that you understand, if I zoom in, I want you to all to understand there really are two solutions, because the curve goes up and the line goes through. Do you guys understand what I'm saying here? But again, you kind of have to look at the whole picture between 0 and 2 pi to know how many solutions there are going to be. So I count 2, 4. And so far on the paper, I've only found 2 of them. Okay? I'm going to pause. I'm going to ask you guys to write down the other 2 equations you would need to solve to come up with the other 2 solutions. And I'm also going to take some questions. Hey, I want to bring up a point here. Justin said that the directions say list all the solutions. One way to do that is to take this theta is pi over 3 plus 2 pi k and then work with that. But what I'm doing right now is just trying to get us those 4 solutions, right? And so the other equations you would want to solve, okay, at least what I would do, is we did pi over 3 minus 2 pi, and we did 2 pi over 3 minus 2 pi. So now I'm going to do x equals pi over 3 minus 4 pi, okay? And I'm going to do x equals, what would the other one be? 2 pi over 3 minus 4 pi. But again, we can't really subtract them this way. How are we going to write them? We have pi over 3 minus, this would be, how many pi over 3's would it be? Sure, because you're going to multiply by 3 over 3. Okay? Molly, go ahead.
Why is it just x instead of minus 2x?
Oh, it is. Well, let's see. It is minus 2x. I'm sorry about that. Because that's what theta can equal. I'm sorry about that. Right. Minus 2x. Thank you. So we get negative 2x is negative 11 pi over 3. And that's how you get a positive value for x. Right. Otherwise, what am I doing? That was what theta equals. So we get positive 11 pi over 6 is the third answer. You could check. That would be one on the calculator. And how about the last one? Let's see. Let me write negative 2x equals, well, this is 2 pi over 3 minus 12 pi over 3. So I get negative 2x is equal to negative 10 pi over 3. So x is equal to, well, either positive 10 pi over 6, but you could simplify that and write it as positive 5 pi over 3. Okay, so I've circled the 4 answers between 0 and 2 pi. I hope this is... I can easily draw pictures of theta, but it's hard for me to draw pictures of x. See, my trig equation is not sine of theta. It's the sine of negative 2x, right? And so you're trying to figure out, what do I put in for x that makes the sine equal to radical 3 over 2? Well, there's lots of things you can put in for x. Basically, what you need to do is get that negative 2x to equal one of these nice infinitely many things. So I guess once I get to this point where I replace theta with negative 2x, I have a tough time talking about quadrants anymore. Okay. I just know there's infinitely many solutions, and I'll get the ones that I want. Okay? Which isn't so simple, I guess. So number 18, actually in some ways it's not as hard as what we just did. You'll see in a moment. So when I do number 18, sine squared of x is 3 over 4. One of the things that's different about this is that here, what am I squaring? What's being squared in that equation? And what's that mean? When I write sine squared of x, remember that's a shorthand. What it really means is something squared. What squared? It means that you're taking whatever the sine of x is and squaring it. You guys aware of that? That's different than this. If I write this, what's being squared? Here the x is being squared, like the angle would be being squared. Do you guys see the difference? Matter of fact, as an aside, I think I'm going to solve this equation separately in a minute. Maybe we'll do sine of x squared equals, well, I guess I'll write 3/4, even though that's not a good problem. This is a different problem. But I want to do it so you guys understand the difference. Okay, we'll do that on the side over here. Okay? If let me do the other problem first. I actually think it may help you. If I were going to do this problem, I would say something like sine of theta is 3/4, where theta is what? Theta is x squared, right? And I would draw a picture, and I would look for a place, an angle, where I don't know what the x-coordinate be, but I would want the y-coordinate to be 3/4. Are you guys with me on that? And do you understand there would actually be two places where that happens? Because there would be another place over here where the sine of theta is 3/4. Who's with me so far? Really? Cool. And if I did that, I could come up here. And what would be an easy way to come up with theta? Well, kind of like this, right? You could do the inverse sine of what? 3/4. But again, this is not the problem I was assigned in problem 18. This is a different problem. And I would get that. And I would say x squared, well, I'd say theta is approximately 0.8481. And so x squared is approximately 0.8481. And so one value of x, how would I get it? Sure, let's take the square root of the answer, right? Take the square root of what I just got. And that would be about 0.92. And then there'd be another answer over here. But that's not the problem that was in the book. Okay? I bring that up because sometimes we do this where we replace what was inside with a theta. But this is different. It's not the thing inside anymore that's being squared. It's the sine of x is being squared. So let's see if this makes sense to you. What I know is that the sine of x is, I can almost just do this. There's only one other thing I have to put. When you take the square root of both sides of an algebra equation, you need to put plus or minus. Okay? Not happy. Justin, did you get that?
Oh, no, yeah.
Okay, cool. So I took the square root of both sides, and I had to put plus or minus because I know that there's two possible solutions for the sine of x. And by the way, this equation should look pretty familiar now, because another way to, how can you simplify the square root of 3/4? We know that's the square root of 3 over the square root of 4. So what I really have is sine of x is plus or minus square root of 3 over 2. What am I going to look at next? Unit circle. And I'm going to try and find all the places where the sine is equal to the square root of 3 over 2, plus or minus. And actually, talk to each other about how many solutions you think we're going to get for x here. Aren't there 4 solutions? Right? I mean, up here I could get square root of 3 over 2. Over here I could get square root of 3 over 2 for the y-coordinate. We know down here I'd get negative square root of 3 over 2 for the y-coordinate. What's the x-coordinate for these guys? 1/2, yeah. Negative square root of 3 over 2 for the y-coordinate. And so, yeah, there are 4 different values. Well, actually, we know there are infinitely many values of x. But again, all he really wants are the values of x between what? 0 and 2 pi. And so let me list those. I guess I would say here, if I had to list the values of x, they would be pi over 3, 2 pi over 3, not 3 pi over 3. This one is 4 pi over 3 and 5 pi over 3. And now if he said list all possible solutions, Yeah, you'd have to add 2 pi k to any of those. Okay. But those are the solutions between 0 and 2 pi. Okay? So that's kind of nice. I want to point out number 15. Not sure if I want to solve the whole thing. It says tangent squared of x equals 3. So what do you think I'm going to do to both sides of this equation? Take the square root. I'll write tangent of x is equal to, what will I write?
Plus or minus radical 3.
Plus or minus square root of 3. And you might say, well, what's the deal with that? Well, that's plus or minus the square root of 3 over 1. And I'm just going to point out that that's plus or minus the square root of 3 over 2 divided by 1/2. And the reason I'm pointing that out is because remember something about the tangent function. The tangent function is the same as sine over what?
Cosine.
So really what this equation says is, hey, look for values of x where the sine of x is square root of 3 over 2 and the cosine of x is 1/2. That's where the tangent is going to be square root of 3. And I'm telling you that I think the answers are going to be exactly the same as they are for 18. Because if you put this sine over that cosine, that's negative square root of 3. So that'll make tangent squared equal to 3. Okay? (21). 21, we up the level of difficulty a little bit. It says the sine of 2x is equal to the cosine of x. You guys, this is a lot tougher at first glance because, do you guys see how I'm dealing with 2 different angles? This angle is 2x and this angle is x. And so trying to draw pictures and figure out where this happens is challenging. So one of the first things I suggest you do when you get to these problems is think about those identities that we've been working on. Okay? So actually, we know an identity for the sine of 2x. So the first thing I'd like you to do is replace the left-hand side of the equation with something that it equals. Let's see if you guys can do that to start. So I have 2 sine x cosine x equals cosine x, right? Okay. Now let me tell you a temptation. Temptation might be, hey, let me divide cosine x from both sides. But if you start dividing out variables, you'll remember from your algebra class you're going to lose solutions, okay? It's better to set the equation equal to 0 and do some factoring, okay? So let me do that. 2 sine x cosine x minus the cosine of x is equal to 0. Okay? And when I say do some factoring, what am I going to factor out here?
Cosine x.
That cosine x. Instead of dividing by it, because I'll lose solutions that way, we're going to factor it out. So cosine of x times what? 2 sine x minus 1. That's what I would have. Remember, factoring really only helps if you have the thing set equal to 0. Because there's a property that if 2 things are multiplied together and they equal 0, we know that either the cosine of x is equal to 0, or the other possibility is that 2 sine of x minus 1 equals 0. Right? So it's interesting because you now have 2 equations, and that's why this is a separate section. It's like the next step. Okay, you can solve one trig equation. Now let's do the problems where you're going to have to solve more than one trig equation. All right. If I have this, cosine of x equals 0, I'm drawing my unit circle, and I'm thinking, where does that happen, guys? Well, we know it happens here, right? Pi over 2. Does it happen anywhere else? 3 pi over 2. So I have x equals pi over 2, x equals 3 pi over 2. Again, plus 2 pi k if I want all the solutions. But again, it says, nah, just go between 0 and 2 pi. So I'm going to get rid of that piece. All right? And now we also have this. 2 times the sine of x is equal to 1. The sine of x is equal to 1/2. Right? So I added, and then I divided. And again, I'm going to draw a picture, and I'm going to try and figure out where does that happen. So again, I'm thinking unit circle. And I'm thinking, where does the sine of x equal 1/2? I think that's here and here, right? Where we get radical 3 over 2 comma 1/2. So what values do I get for x there? One of them over here is pi over what? 6. And then the other one would be 5 pi over 6. So I think we're getting stronger at this stuff. I do. Moving on. Let's look at 27. Let's look at 27. So we have 3 times the cosine of 2x equals the sine of x plus 2. All right. Now I'll tell you what my first hunch would be. I know the cosine of 2x from my song. Cosine, cosine, sine, sine. My first hunch would be to do this. But if I do this, I'm going to end up being, well, that's going to take me some time. So if you used another form of the identity, you can get by it. You can get away with it. You can do the problem more quickly than I'm about to do it. I'm just kind of showing you what would come naturally to me. Cosine, cosine, sine, sine. And see, I don't think that it's going to work like the last one. I'm not going to get a common factor all the way through. In the last problem, there were cosines everywhere. Here, there's not cosines everywhere, there's not sines everywhere. But what you can do is instead of writing cosine squared here, I know that that's the same as 1 minus sine squared x. So let me write this very carefully. So I think what a lot of people would do to start this problem would be to write this. 3 times 1 minus 2 sine squared x is equal to the sine of x plus 2. I have a feeling that's how a lot of people would start this problem. They know that cosine of 2x is the same as 1 minus 2 sine squared x. For me, I would probably work it out through a few steps. And the good thing is, at least everything now is all sine of x. So if I can get that far, let me distribute the 3. And again, if you just think of sine of x as being the variable we're trying to get by itself or isolate, what this equation is really like is your old algebra class where you had 3 minus y, or 3 minus, here, let me write it this way. 3 minus 6y squared is equal to y plus 2. That's really what this is if my y here is sine of x. All right? Now, would you guys know how to solve the green equation? What would be the next step? And set it equal to what? You got to set it equal to 0. So that's exactly what I'm going to do here. I'm going to set it equal to 0. I'm going to write 0 equals So let me see if I do this right. If I bring this to the other side, it would be positive 6 sine squared x plus sine of x, and then I guess it would be minus 1. Just like here, you would have 0 is 6y squared plus y minus 1. It's funny how some people will actually make the substitution, and that helps. Or you could just kind of think about it that way. And then how would you solve the green equation? What could you do next?
Factor.
You could do factoring, or if the factoring doesn't work, what else could you do? You could do quadratic formula. You guys remember that? Negative b plus or minus square root of b squared minus 4ac all over 2a. Y equals that. So the sign would equal that. And believe it or not, if you work through that formula, it's going to work. Now, I am really hoping that he gave me something that factors. And you're hoping that too. Do you think he did?
Yeah.
Well, let's hope he did, right? I mean, I'm hoping that what's happening here, I mean, the only way to get negative 1 is plus 1 and minus 1. 2 and 3, does it work?
Yeah.
You need to put the 2y with the plus 1 and the 3y with the minus 1. Yeah, thank goodness. Okay? So, really, the next step, you could argue, is this. 0 equals 2 sine of x plus 1 times 3 sine of x minus 1. With me, Brad? Okay?
Mm-hmm.
So again, it's thinking of the trig function as what you're trying to solve for. Just like you did in algebra class, solve for y. We're solving for sine of x. As a matter of fact, it may help you to do this, because now, what are the two different y values we could get? We get y equals, what do you get from this guy? Positive or negative? It'd be negative 1/2. And what's the other one? Y equals
1/3.
positive 1/3. So what I get here is I get sine of x is equal to negative 1/2. And from here I get sine of x is positive 1/3. I'm just trying to do this a little more quickly for you guys so we can actually finish. And now I have to find x values, right? And this is where drawing the picture can help. So where does that happen? That the sign is negative 1/2. Well, it happens, I know, down here, right? And there. And so it looks to me like x could be, I think that's 7 pi over 6 or 11 pi over 6, right? Because we all want all the ones between 0 and 2 pi. And now this one's more of a pain. How the heck do I solve that? Is that on my unit circle picture? Well, it's not one of the ones that's really nice, right? Let me draw it, though. Yeah, nice unit circle, Paul. That was awful. Well, we'll deal with it. All right, so I know that 1/2 is like here, and I know that somewhere in between here there's a point, I don't know what it is, that it equals 1/3. Okay? So the question is, what value of x would that be? Well, one of them I can get by saying x equals the arc sine of 1/3. And that's that one. Right? If the sine of x is equal to 1/3, one of the angles where that happens is when x is the arc sine of 1/3. And that'll be in quadrant 1. So talk to the person next to you about where is the other place that the sine will equal positive 1/3. Which quadrant are you going to be in? Isn't it true that this black angle, which ends in quadrant 2, would also work? I mean, where the y values are exactly the same height. Now, I can't get that from arcsine. The reason I know that is, what's the range of the arcsine? That was something I've been trying to memorize. Range of the arcsine, I know, is negative pi over 2 to pi over 2. So I'm never going to find that black angle just by doing arcsine. Okay? Arcsine will give me this blue angle. You with me? So to get the last angle, the black one, we get the black angle by doing, and let's see if this makes sense to you, pi minus the arcsine of 1/3. Because what's pi? How many degrees? 180. And would you agree that this angle in here, which I just denoted in blue, is the same as that angle right there? Yeah. So it's pi minus that blue angle. And so I claim that the fourth answer to problem 27 should be this. So there they are. Those are the values I would get for number 27. Is that what he put?
Yeah.
Okay.